Hello everybody and welcome back to the stream. So I've been away from the stream for a couple of weeks and there is a reason. Hopefully it's a good one. I was pretty busy with preparing stuff that I wanted to show a lot earlier. And it turned out it was more complicated than I thought it would be. But before we can continue, let me quickly refresh this here. Let me see. Why is the chat disconnected? Let me double check the ID of the stream. Maybe we don't have a chat today. All right, let's get this fixed. And while I do this, maybe you can just say hello. Okay, so we've got our stream ID. Get this into OBS. Have the pop out. How's that? Nope. Nope. All right. Okay, so no on-screen stream today. So what I will do is I'll go and pop out the chat on my other machine so I can see what people are saying. All right. How do we do this? Top chat. Come on, pop this out. Oh, there we go. Ah, it was just a matter of somebody saying hello. Well, hello. It's good to see that this is working. All right, so I was at a conference a couple of weeks ago. It was Swift Leads, and I presented on async streams. The recording is live, so let's go and have a quick look at that. So we can go to YouTube Swift Leads. Here we go. So this is the talk that I gave. Oh yeah, and by the way, my luggage got stolen, so I started the talk with talking a little bit about how my luggage got stolen, which was a little bit unfortunate. But yeah, so the rest of the talk is about a little sample app that I built and how to use different forms of techniques to implement asynchronous events. So we've got delegates. Let me pause this. So we've got Objective-C delegates, and maybe we can make this look better. Cinema mode? Yep, cinema mode. So we've got delegates in Objective-C. Then we have delegates in Swift. And we have callbacks in Swift. And then at one point, we get combine. And if you implement something in combine, you get those really nice publishers that publish events, and you can use operators like map or catch or assign to operate on the events that you get. So for example, in this snippet here, we have a location manager. So every time you move the phone, you will get a location update. And the first thing that we do is we map this location, and we make sure that if there is an error, we'll send nil, and then finally we assign this to a property on our observable object here, on the location object, and that we can use in our UI to display the current location. And my sample application is a simple compass app, so it shows the orientation of the phone, and in the background it can also display a map of where you currently are. So this is how you consume events using Combine. And then in Structured Concurrency, the same thing for using the location manager. Let me see. Becomes this, right? So you can request a single location, and then you can assign that to the location, but that is just a single location. So what about when we want to get more locations, right? So we want to get location updates. So that is where streams come in. So when you implement streams, you can consume the stream using a for in loop, or rather a for await in loop. So here we have a location manager sequence that I showed on the previous slide. And once you start this stream, it will start sending updates, and you can consume those updates using for try await like this. So let's take a quick look at the sequence that I implemented. So here is the sequence. We get our location manager, and then we have this property location updates, and that returns an async stream of CL location. And to create this stream, all you have to do is call the initializer, and you will get a closure, and in the closure there's a continuation. So you'll store this continuation, and then once you start receiving the updates from the location manager, you can then send them to the continuation. You can see that down here. So we've got our regular callback, and this is all behind the scenes. So we're hiding this from our users. And whenever we get an update in our location manager sequence from our location manager, we'll yield this to our location continuation. And that means that the stream will emit another value, which is locations.last, and this will be inserted into the stream that consumers of location updates will receive. So that is a relatively, it's probably the simplest way to talk about async sequences that you can get for something that connects to a real API, other than producing numbers, for example. Okay, so and then at the end I gave this example of how we implemented this for Firebase. So here we see an example of how you would typically use Firestore in this example. And to receive real-time updates from Firestore, you would typically register a snapshot listener, like here. So we call query.add snapshot listener, and then every time there is an update to this to-dos collection, the snapshot listener will receive an update. And when we receive that update, we will map all the documents that are in this snapshot and assign them to this property on our view here, and then the UI can update. Yeah, this is I agree. This is one of the really nice things of Swift concurrency. And the interesting thing is when I first saw this, so I implemented an early prototype of this a couple of years ago. And when I first saw it, I thought, well, this is really interesting because we go from something that looks like this, where we have our snapshot listener, and we have this structure here, to something that looks like, let's see, where is it? Snapshot listeners. Okay, let's go on a little bit, to a for loop. And in the beginning, I found this quite interesting. And I thought, well, is that a good way to think about asynchronous events? And if you think about why they call Swift structured concurrency, the main reason is that I think in one of the introductory sessions about Swift concurrency, they say, well, as developers, we have gotten used to all those ways how we can write programs, all those structures that we can use, right? So in the beginning, when in the olden days, before we had higher level programming languages, we had everything was very basic. So let's look at a simple program. So hello world, and then go to 10, and that was your loop, right? So to implement a loop, you would go to, and that is not structured. And then at one point, people realized, well, this is no good way to implement programs that are moderately complex. So we need something better than this. So they came up with for loops, right? And that was the first time that we talked about that. This was called structured programming because it gave your code a structure. So instead of just wildly jumping around using goto statements, you would have for loops, for example, or you would have if statements. I mean, this is this is a bad example of, this is not structured code, because this is literally the same loop that we saw just before, but using an if statement, right? So we assign 1 to I, we print hello world, we increment I, and then we do a quick check if I is less than 5 or equal to 5, and if so, we'll jump to line 10, print hello world. So this is our loop here, and this is the structured loop. Okay, so and the Swift team said, well, we're calling structured concurrency because we're applying similar paradigms to concurrency as we did for regular programming. And this is why we end up with code that looks like a for loop, right? So this here. So perfectly fine, I think. All right, so let's see what's going on the chat. Okay, I'm too quiet. That's interesting. Because my audio level is in the yellow area. Maybe you need to increase your volume. I don't know. Maybe others can let me know if I'm too quiet. So Mr. Uno says, I'm currently doing a lot with async sequence and it's such fun and great design, but I prefer to always implement a custom asynchronous for each function. Yeah. And do you know when callbacks were first introduced? You mean in Swift? Or, I mean, Objective-C had callbacks a long while ago. I mean, we can go and ask. Let me see. Okay, when were callbacks introduced to Swift and Objective-C? They've been around for a long time. I want to say maybe 2009? Let's see. All right, here we go. Modern callback functionality was introduced with blocks. For those of us who still remember those times. Introduced in Snow Leopard in 2009. Yeah, you had target action and delegations. And for Swift, you know, they were in the language right from the beginning in 2014. So yeah, they're really, really, really important. Okay, so I don't know. Let me see how the volume is on my end. For Swift, you know, they were in the language right from the beginning. I think it's good. Lars, it might be something on your end. Okay, right. So, and when I came back from the conference, I thought, okay, next week I'm going to do this live stream here, and then I'm going to demonstrate how to use this. And then I implemented this in my Second Brain application, and everything worked fine. But when I signed out the user, I could still see the data, and I shouldn't have seen the data. And it turned out that I was missing a key piece, which is the flatMapLatest operator. So let's go into the code, and I'm going to demonstrate how you can use that in your own code once everything becomes available. So let me see, is this nice? Yeah, I think this is good. Okay. So we are in the remote artifact remote store, and this is the code that we've written before. So here we have the enable live updates method, and the key piece is this part here where we have access to our collection. So we have our Firestore instance, we tell it we want to listen to a collection, and we have a query on that collection saying that we are interested in all the documents that belong to this specific user here. And we have the user ID somewhere in our remote artifact store here. And we'll come back to this structure here in a moment. And then we order that by creation date, and then we will set up our snapshot listener, and everything inside this snapshot listener, inside this closure here, is the snapshot listener. So first of all, we will have a defer block that will update this field here so that we can display when the data was updated the last time. Then here we will make sure that we actually got some documents. So if we don't get any documents, we will just set the local artifact to an empty array. And if we got some documents, we will perform a compact map on that. And inside the compact map, we use document.data as. And data as is one of the features that we added to Firestore a couple of years ago, and they empower you to use combine. They allow you to use Codable to map your Firestore documents to a local structure. So here we have the Firestore artifact struct, and it has lots of fields. And you can imagine that maybe you might have an even bigger struct in your application. I think this is reasonably well structured, but I could easily imagine writing an application that has way more fields. So this might be way more attributes here. So in the past, you would have to map all of this manually, but thanks to Codable, you can do this with one line using the data as, and if we click here, we can see that this works on decodable types, and we provide the type using this as parameter. So that's what we're doing here. And then by using try question mark, we'll basically say, okay, you go ahead and try to perform this operation here, and if it succeeds, then we'll return this value. But if it does not succeed, we will not throw an error, but we will return nil. And the compact map will go over all those elements, and it will just filter out anything that is nil. So now you might be wondering, why is that even relevant? So it is relevant in case that you have something in your that you have a mismatch between your Swift struct and the document. So here everything is optional, so that's not a problem. But let's say if the URL, right? So for example, so the URL is not optional. So now let's imagine that I had a document in my Firestore database that didn't have a URL. So now Codable tries to map the document to this Firestore artifact, and then it realizes, oh, URL is not optional, but I don't have a URL field in the document, and that's an error. So what should it do? Should it write an empty string? That is incorrect. Should it store nil? It can't store a nil because URL is not optional. So it has to throw. And for those cases, we use this construct where we'll say, well, in case it throws, we'll just assume that you couldn't map that, and then we'll just return nil, and it gets filtered out. This is a pretty naive way to handle that, but it allows me to keep this code compact. In a more real application, you would probably have more elaborate error handling where you try to say, well, can we recover this? And if we can't recover, we might log this and log this to a place where the user can later go and say, okay, I was expecting to see 10 documents, but I only saw 5, so what happened? And then you as a developer can say, well, can you send me your log? And then in the log, it might say, well, we tried to map this document, but there were fields missing. And then you could help the user out by saying, you need to do this in order to fill in all the missing fields. Okay, so that is how you currently need to do it. There is a bunch of housekeeping that we need to do. So one of the housekeeping aspects is we need to hold on to this listener registration. So the listener registration is a handle, if you will, for that snapshot listener. And whenever you no longer need that snapshot listener, you should remove that listener registration in order to tear down your snapshot listener. Because, and maybe we can go into the console and I can show you that. Is it this one? So if we go to, yeah, it looks good. So if we go to Firestore database and then we go to usage, you can see that you've got your reads and writes. And here you can see your snapshot listeners. So at the moment, this application has 2 snapshot listeners that are active. And if you have too many snapshot listeners, then that's not a good idea, right? So you want to limit the number of snapshot listeners. So you want to remove the snapshot listener if you no longer need it. And to do that, we have a bunch of things that we do. So we have this remove listener function here. And then in the dinit of our artifact remote store, we will call remove listener. So every time this artifact remote store gets removed from memory, it will automatically also remove the listener registration. But you can see that in order to bookkeep my listener registration, I have a bunch of code that I need to write. So I have to have this one line here. Then I have to write these 3 lines of code here. I'll have to do this. Okay, I could probably roll this into that one. And then I need to remove the listener when I set up a new one. And I also need to remember to set it up once I actually add it, right? So that's a lot of code, and it's easy to forget that. Async streams allow us to get rid of all of that. So now let's try to convert this code to make use of this new async stream feature. Okay, so I'm going to create a new function with the same name. And then we'll just rename this one so that we don't have a duplicate. And then what we want to do is we want to listen to the authentication state changes. Why? Because we need to get the current user ID. Right? If we were to fetch all of the data from the database, for example, if the collection that we need to listen to is a product catalog, a public product catalog, then we wouldn't have to use the authentication object. But because we want to read the user's personal data, we need their user ID. So we need to get an event every time the user signs in or signs out. So for that, we use the auth state changes. And the auth state changes is an extension method on the auth object. So here is the code that I added to the Firebase SDK to support this. It's a public extension. Can we see that? So here we are in the Firebase auth module for Firebase. And here is an example of how to use it. And here you can see it returns an auth state changes sequence. So if we look at the auth state changes sequence, you will realize this is slightly more complicated than the code that I showed you, that I presented at Swift Leads. And the reason for that is this here is sendable, and the code that I had when I presented at Swift Leads was not sendable. So we need to have this sequence here in order to make the whole thing sendable. Also, you will realize that I'm using unchecked sendable, and the reason for that is, it's also documented here, the auth object is not sendable. So we'll have to say, don't worry, dear compiler, this is absolutely fine because we guarantee that there are no changes being made to the auth object while we iterate on this sequence. Okay, so we've got our auth state changes, and the next thing that we need to do is we will have to use the share operator. And the share operator is something that I imported from the Swift Async algorithms package. So why do we need that? Well, the thing is, for sequences, you can imagine this as, it's like if you have a slide on the playground and you have a bunch of marbles rolling down the slide. And now let's imagine that a bunch of people are standing at the front of the slide and they grab a marble, right? So let's say we've got Mr. Uno and Lars and Peter, and we all stand at the bottom of this slide. Somebody is sending down marbles every couple of seconds, and we all want to use them, right? So, and we're standing in a row. So Mr. Uno is the first one, and then after him there is Lars, and I'm the third one. So a marble comes down, Mr. Uno grabs the marble and takes it. Now it's gone. So he does whatever with the marble, for example, inspect the marble, but he doesn't put it back because he consumes it from the stream. So the next marble comes down the slide, and Mr. Uno has processed the first marble, so he'll take the next marble, and so on and so forth. So there are no more marbles for Lars and myself. So, and that is why we need to use the share operator. The share operator basically says, well, I will duplicate the events that are being passed through the sequence for every consumer that is subscribed to the share operator. And that means if you, you could imagine it like some sort of switch that you install at the bottom of the slide. So a marble comes down and it goes into the switch, and the switch says, I know that there are 3 people who want to consume these marbles because they have registered with me. So I will now take this marble and I will duplicate it so that every one of those consumers can have their copy of the marble. Okay, so and that is why we use the share operator, because we'll pretty likely want to consume the auth state changes in a different place in the application as well. Good. So the next thing that we need to do is we'll need to flatMapLatest. So flatMapLatest is an operation that is also part of the Swift Async algorithm package, Swift Async algorithms package. What a complicated word. But only on my fork of the repository. So this is on me to contribute this back to the project. And what it does is it listens to the outer sequence, and whenever there is a new event on the outer sequence, it will cancel the inner sequence and restart it. So in our example, the outer sequence is the authentication state listeners. So let's say the application starts up and the first event is no user is signed in. So you will get nil. So this flatMapLatest operator gets nil, and then it will start the inner sequence and it'll say, well, here is your element, it's nil. And then the inner sequence can do whatever with that. And then, for example, it will start listening well, it can't listen to any documents because there is no user. So it won't do anything. But now the user signs in and we get a user object, which is then sent to flatMapLatest. So flatMapLatest realizes, oh, there is a change, and it will cancel the inner sequence, which was listening to nothing, and it'll say, well, I'm starting the sequence from start with this new object, with this new user that has just been passed in. So that inner sequence can now subscribe to a Firestore document for that user. Let's say it's 123. It listens to all the documents for user 123. At one point, the user signs out again, and now we get nil back, and that means flatMapLatest gets nil on the outer stream. It cancels the inner stream, so now the inner stream doesn't listen to any collection anymore. A new user signs in, let's say it's 345, and then flatMapLatest cancels the inner sequence and restarts it with this new object. So that is how it works. Okay, so flatMapLatest. We get our element in, and it is a user. And we can even go and say, okay, so what is on the user? So we can see the user's ID, for example. But what we really want to do is we want to use Firestore and listen to a collection. So we want to listen to this collection here. But we also want to filter that. So we want to filter where field, and which field we want to filter is user ID, and we want to only get the documents where the user ID is equal to the user's ID. All right, and then what else? We want to get the snapshots for that. So snapshots is another sequence, and it works pretty much the same as the authentication state changes sequence, but instead of listening to any signed in or signed out users, it will listen to document changes. And again, here we can see that it returns a query snapshots sequence. In the beginning, the code was a lot easier, but to make it sendable, I had to implement this custom sequence here. And the code that actually listens to the Firestore collection is this part here. So you can see that we have the query, we add the snapshot listener, and whenever we get a snapshot, we will yield it to the continuation so that it will be sent into the stream. So now if you remember that we had to do bookkeeping for our snapshot listener when we implemented ourselves, here you can see that we don't have to do that. Well, the user doesn't have to do that because I implemented it here. So we have our snapshot listener and we store it into listener. And then whenever the continuation terminates, we will just remove the listener, just like that. So that removes all the bookkeeping because it moves the bookkeeping into the library. Nice. So we get the snapshots, and then we want to compact map the snapshots. So we get the query snapshot, and then we'll just say query snapshot dot documents dot compact map. And we have a query document snapshot, and then we can do just what we did before. Try query document snapshot.data as Firestore artifact.self. Okay, so what's happening here? Okay, so the result of this call will be a flat mapped collection of documents. So we'll have to assign this. Let artifact updates equals this piece of code here, and then indent it. Okay, and now for the magic part, for await artifacts in artifact updates self.artifacts equals artifacts. Okay, and this needs to be async. And it can throw oh yeah. Okay, let's do more error handling. Catch and print the error. Okay. So this is the main chunk of code that we need. So once we call this function here, it will first set up the stream. So artifact updates is our stream, and then we iterate over the stream. And the interesting thing to note here is this stream will never end, because this snapshot listener goes on forever, right? Because we want to listen to any updates coming from Firestore for the entire runtime of the application. So that is why this never ends. This is different than, for example, if you'd, for example, say url.lines in order to read all the lines from a URL, and you provide a URL to, let's say, a file. So you'll get all the lines of the file, and once the file has been completely sent to the stream will end. But here it will not end, because we will keep on getting updates whenever anything changes on the collection. Cool. So I think we can remove a bit of code. So first of all, oh yeah, and let me remove a bunch of code. So first of all, we can remove this code here. This we can also remove. All of this we still need. Okay. And then we will handle this live updating slightly differently. So we'll remove that. And if you look at this, you will see that we're using a side effect here in order to call enable live updates whenever this user ID changes, right? So whenever somebody sets the user ID, we will call enable updates. So let's have a quick look at where this is being called from. And you can see that this is one place where it's being called from, right? So whenever the current user on the authentication service changes, we will set this user ID. And while this works, it is a lot of, wiring, So you as a developer have to be aware that you have a bunch of services, and in order to interconnect them, you'll have to do manual wiring. And I think, well, that is very error prone, and I'd like to get rid of that. So instead of doing that, we are going to do this. So we will have a task that will be run when the application starts up, and we will call enable live updates on our remote store here, and I assume we might have to make that public in order for that to work. And that also allows us to basically remove those couple of lines of code. Let's see if it compiles. Hey Stefan, good to see you. The stream is looking sharp because we're streaming in 4K. So it compiled. Let's see if I didn't forget anything. Okay, so things are looking good so far. We have all our documents that we got from the inbox. Oh, and let me pull up the database. Oh well, there's already too many documents in here, so it will be hard to see the changes. Maybe we got lucky. Let's try. Nope. Let me scroll down a little bit. Nope. Well, anyways, so so this works. Let's see what happens when I sign out. Okay, so this worked fine. We have no more documents here. And now let me try to sign in again. And I need to get my password for this user. Where are we? Sign in with password, paste, sign in. And here we go. We have our documents. Nice. So let me try running this on an additional simulator, and then we can experience the real-timiness. So let's bring both of the simulators to the front. Oh, the second one is starting up. Well, let's put it here. Okay. Right, so we've got our second simulator starting up. Oh, and because this is starting up for the first time, I will have to do the whole sign into your iCloud account dance. Okay, so sign in with Apple, yes. Sign in manually. Oh, just once, please. Okay, and now the password. Okay. While this is signing in, we can go back here. Nice. What? Oh yeah, sure. And then we can sign into the application. Let's see if the paste buffer still has my password. It has. Nice. Okay, so, and now when I make changes, they're reflected in the other app pretty much immediately, thanks to the real-time snapshot listeners that we're consuming via an async stream. So, and I think this is pretty nice because it allows us to keep our code local, and I personally find it easier to reason about this than having to spread this whole code over lots of different places. So instead of having to wire up my my different services somewhere, I'll just say, well, I want to listen to this service here, and whenever there's a change, I want to do something differently over here, right? So for example, whenever user signs in or signs out, I want to change how I subscribe to the Firestore collection. Yeah. And we don't have to do the housekeeping, right? So because everything is happening automatically behind the scenes. Cool. So that was what I wanted to share with you today. I hope you enjoyed it. Now, as for what remains, so there are still a bunch of things that we need to finish. So for example, if we look at the source code, so we have support for async sequences for Firestore. I implemented it for authentication as well. There is support for real-time remote config. So that means you can listen to any remote config changes as well. But I haven't yet implemented the sendable compliant sequence. So if we look at remote config Swift, oh, it's over here. Should be in here. Yeah, so you can see that the code is pretty much similar to what I showed you for authentication and Firestore. So you have your for, try, await, config update, and remote config.config updates loop, and then you get all the updated keys, and then you can do whatever you want. You can decide when to activate them and when to assign them to your UI and stuff like that. But as you will notice, when we go into config updates, you'll see that instead of having this sendable compliant specialized sequence, what I'm doing here is I'll just use an async throwing stream and I pass it out as an async sequence. And that is not sendable. So I need to implement this sequence here to make it sendable, and that should be done. And then I also need to implement support for real-time config, real-time database, the RTDB. So that's missing as well. And then, of course, as I mentioned, I'll have to convince the maintainers of the Swift async algorithms package to accept my flatMapLatest implementation. So that will probably also take a little while. And in the meantime, I will probably ship this as a shim. I'm not quite sure if we're going to add this to the Firebase SDK or if it's going to be a separate package that you can download from somewhere else, or if we're just going to make this available as a gist. But it's pretty essential because it is the key to combining two streams and reacting to what's going on the auto stream. All right. And with that, I think we can wrap up and everybody gets back the rest of their day, their evening, or their morning, no matter, depending on where you are on this planet. So let me switch over here. So let's see. Oh no, let's go back here because In this week's newsletter, I included a list of the next conferences I'm going to speaking at. So first is DevFest Hamburg, where I am going to talk about, where are we? Well, I'm speaking there. Should be somewhere. Here we are. So where I'm talking about Firebase AI logic, and I think this talk should also have hybrid AI. I think so. Maybe not. So I'll try to include the part where I show how to switch dynamically between Apple's foundation models and Gemini, depending on your use case. After that, I will be in Bletchley Park with the same talk. And then I'm going to I'm going to host NSLondon at the Google office on November 26th. And there I'm going to definitely talk about hybrid AI with Firebase AI logic and Apple Intelligence. And quite interestingly, there is going to be another talk by Hannah, who's going to talk about Swift UI and Jetpack Compose. And that is pretty interesting, I think, to see this in comparison. And the final talk is also pretty exciting. It's about AI accelerated mobile development from idea to building faster than ever. So I'm super excited about all of those talks. And if you can make it, say hi. I hope that we'll be able to host as many of you as possible. We'll have a capacity of 180 people at the Google office. So, and they're going fast. So I think the organizers are opening this up in batches. And when they opened up the first batch of 100, I was gone in a couple of minutes. So hopefully we'll get as many people as possible in, and hopefully not many people will be disappointed. Okay. And that means there might be a live stream next week, but I'm not entirely sure on which day. So I'll let you know. Subscribe to my Blue Sky handle and you'll learn about it. All right. Thanks everybody for joining, and I will see you in the next one.